Hello, Hopewell. This is Mr. Steinberg. Today's lesson is 9.4, Evaluating Inverse Trigonometric Functions. Since we're going to do the inverse of trigonometric functions, it's probably a good idea to remember and recall what trigonometric functions do so that we can undo them. For example, let's say the sine of 120 degrees. What does that equal? The sine is a trig ratio of opposite over hypotenuse. 120 degrees represents the angle. This is our input. In a trig function, we input an angle. What does it give us as the output? It gives us the output is a ratio. It's the ratio of opposite over hypotenuse. For 120 degrees, you can use your unit circle to do this, but I use my fingers. 120 degrees ends up in quadrant 2. Quadrant 2, our y-coordinate should be positive, so the sine value should be positive. Quadrant 2 reference angle of 120 degrees would be 60 degrees, so I'll fold down my 60 degree finger, 0, 30, 45, 60. That's my index finger. The sine coordinate corresponds to the y-coordinate of a point on the coordinate plane on the unit circle. The y-coordinate would be square root 3 over 2. The y-coordinate is positive. That's why this is our answer. This is what a trig function does. You input an angle, the output is a ratio. Today what we're going to do is for specific trigonometric functions, we're going to find their inverses. What does that mean? We're going to switch the input and the output. I'm going to spare you the talk about inverse functions and their relations for right now. Only when it's important will I bring it up. So we're going to switch the input and the output. So I'm going to start by giving you ratios and you're going to find angles. That's pretty much what the objective says here today. Here's our warm-up. Use your unit circle to answer the following. Again, I use my fingers. Find the angle whose sine is 1/2. They're starting us with a ratio. They're giving us, and they're going to ask us to find an angle. The sine value represents the y-coordinate of a point on the coordinate plane. So we're looking for the angle. That means we must have the y-coordinate of 1/2. So if my y-coordinate is 1/2, I need folded fingers below. I need the number of fingers below my folded fingers to be 1. So I'm going to fold my ring finger. That's 0, 30 degrees. 30 degrees would be a solution. Are there any other answers? How about there might be a sine value that's positive in the second quadrant because the y-coordinate is positive in second quadrant, which I think implies that 150 degrees is also another answer. Also, other complete revolutions around the unit circle would give us alternate answers of angles that have a sine value of 1/2. So I'd add 360 to each of these answers. I could also subtract 360, one full revolution around the circle. If I subtract 360 degrees, I get another alternative answer. How many answers can you find? I can find an infinite number of answers. There are an infinite number of angles that have a sine ratio of 1/2. I don't have the time to go through that and find all infinite answers, so I'm going to move on to question 2. Find the angle whose cosine value is negative root 3 over 2. The cosine function represents the x-coordinate of a point on the unit circle. So the cosine of what angle gives you an x-coordinate of negative root 3 over 2? X-coordinate of root 3 over 2 would be folded fingers above, so the number of fingers above my folded fingers needs to be 3. This would be a reference angle of 30. Now 30 degrees is a wrong answer because the cosine of 30 degrees would be positive root 3 over 2, not negative. When is the x-coordinate negative? In the coordinate plane, the x-coordinate is negative to the left. That would be quadrant 2 and quadrant 3. Now 30 degrees has something to do with it. This is our reference angle. So if I draw two reference angles of 30 degrees in quadrant 2 and quadrant 3, that would correspond to an angle of 150 degrees or an angle of 210 degrees. These are two possible answers. Also involving negatives, we would get some other answers, or adding and subtract 360. So these are also other answers. If I go negative 210 degrees, that brings me back to the same terminal side as positive 150. So how many answers can you find? We can find an infinite number of answers, and we won't. Alright, so that's pretty much the warm-up. I'm just going to try to go into what this does. When there's something important that we need to talk about, we'll need to talk about it. So in order to obtain a unique angle when finding an inverse trig function, we must restrict the domain of each function. Okay, so what does this kind of mean? Today what we're going to do is find the inverses. So we're going to feed in an inverse, we're going to feed it a ratio and come out with an angle. That's sort of how this all works. What types of sine ratios can we plug in? The sine of the points on a unit circle are 0, 1/2, root 2 over 2, root 3 over 2 is 1, root 3 over 2, root 2 over 2, 1/2, 0, negative 1/2, negative root 2. So keep going, negative root 2 over 2, negative root 3 over 2, negative 1, negative root 3 over 2, negative root 2 over 2, negative 1/2, and then 0. So it looks like the maximum sine value we got was a 1. The minimum sine value was negative 1. So that's why this is restricting our domains. The input for a sine inverse can only be a ratio between negative 1 and 1 because that's the farthest the y-coordinate is away from a circle, or the center on a unit circle. Now, we are going to say we're finding inverse trig functions, which means the definition of a function, one input can correspond to at most one output. I don't want to find an infinite number of angles. So we're going to actually do something to this function so that we're only going to return one answer only. There's really 3.5 rules for doing these inverse trig functions, and they are as follows. You want to always include quadrant 1 for your inverse functions. You want to always include quadrant 1 because you want to measure right triangles with acute angles, and acute angles fall between 0 and 90. You want to span all the possible ratios. You want to go from the minimum to the maximum. All possible ratios is the second guideline. All possible ratios for sine are between negative 1 and 1. So I want the y-coordinate to be positive 1 and negative 1. So I want to include two quadrants, one quadrant that's positive, one quadrant where the sine coordinate is negative. Finally, you want this interval to be continuous. Continuous means there's no gaps in it. So I want to use quadrant 1, and I can't use the quadrant 3 values because they're not continuous. There's a break in between quadrant 1 and quadrant 3. So it leaves me to use quadrant 1 and quadrant 4. So the sine inverse, I want it to return angles between negative 90 degrees and 90 degrees. Now why did I use negative 90 to 90? Because that is a continuous interval. I didn't want to say I want it to return angles between 0 and 90, 270, and 360. So I'm going to use negative 90 to 90 because that is a continuous interval that spans all the possible values of sine from negative 1 to positive 1. This is a little bit of the notation. You are familiar with the inverse sign or symbol. This is what you may not be familiar with. This is the same way as writing the sine inverse. It's called arc sine. Basically what this says in math lingo, it says if you are given an arc of this length, find me the angle. Okay. So let's see how this all works. The sine inverse of root 2 over 2. The sine is the y-coordinate, as we remember from above. We need root 2 over 2 to be the y-coordinate. So I'm going to take my fingers, I'm going to find my reference angle, root 2 over 2. So 1, 2 fingers, fold down the middle. 45-degree reference angle. Now, the sine of 45 gives me positive root 2 over 2. It's in quadrant 1. 45 degrees is my only answer. 135, although 135 degrees does have a sine ratio of root 2 over 2, it's not within this zone of a continuous 180 degrees, so the answer is only 45. I want one and only one answer. Now, I don't know how we got negative 30 degrees as an answer for number 2, but let's see how we do this. The sine inverse of negative 1/2. When the sine is negative 1/2, what's our angle? It looks like it's going to give me something that's negative. 1/2, the sine, the y-coordinate. The sine is this, so 1/2. That's 30 degrees, but 30 degrees positive gives me a 1/2. 30 degrees negative gives me a sine ratio that's negative. That's how an inverse works. We're going to feed it a ratio. It's going to tell us an angle. Now, cosine and tangent, they both have different rules than the sine does, but maybe some similarities. Cosine inverse. Cosine is the x-coordinates on a unit circle. The maximum x-coordinate was 1. The minimum x-coordinate is negative 1. Here are the rules for your inverses. We want to always include quadrant 1 because quadrant 1 represents our acute angles in our right triangles. We want to span all possible values between 1 and negative 1. We want it to be a continuous interval. Now, cosine is negative in quadrant 2 and in quadrant 3 because the x-coordinate is to the left of the origin. So I can either use quadrant 1 and quadrant 2 or 1 and 3. Now 1 and 3, they're not connected, it's not continuous, so we're going to use between 1 and 2. So we're going to be given angles, or sorry, we're going to output angles that are between 0 and 180. I'm going to go back to the domain and range above in a second. We'll do that last. So here's the thing. We're actually never going to use quadrant 3 ever. That's really, I said there are 3.5 rules. The half rule is we'll never, ever, ever return an angle for an inverse that's in quadrant 3. Let's see how this works. The cosine inverse of root 3 over 2. Now the cosine is the x-coordinate. I need root 3 over 2, so that's 3 fingers. Fold down my ring finger, that's 30 degrees. Now is the answer 30 degrees? If I say 30 degrees, my cosine is positive, that's true. 30 degrees. If not, the answer would have been 150 degrees if the cosine were negative ratio. So what's the cosine inverse of negative 1? What point on the unit circle has an x-coordinate of negative 1? That occurs at 180 degrees. One more time, we're going to go through the domain and range last. Inverse tangent. Well, tangent doesn't suffer the same sort of restrictive values for the inputs of your ratios. Tangents could be anything that's from 0 to infinity. You can have an infinite opposite side over adjacent side ratio. The closer you get to 90, the larger that tan value gets. If we had some class time, I would tell you, maybe we can do this in a bonus video, what happens as you approach the tangent of 90 degrees. As you get closer and closer, you plug in the angles. What is the tangent of 90 degrees anyway? The tangent of 90 degrees corresponds to the point 0, 1. The tangent is the opposite over the adjacent. 1 divided by 0. That's undefined. So really cool things happen as you approach 90 degrees. So I don't think I can use 90 degrees as an output, because 90 degrees as an input doesn't return anything. It's undefined, as you see off the page there. So we can plug in any real number into the tangent inverse and get an angle. We always want to include quadrant 1, and the tangent would be negative in quadrants 2 and 4, so let's decide which quadrant we want to use. 1 and 2, that's a continuous interval. I could do like cosine and do between 0 and 180, but I'm actually going to use quadrant 4 instead. How come I'm going to use quadrant 4? Because tangent would be negative in the fourth quadrant, positive in the first quadrant. But because the tangent of 90 is undefined, I don't want there to be any gaps in my interval. This is going to return values between negative 90 and 90 degrees. Okay, let's try this. The tangent inverse of the ratio 1. I need 1 to be my ratio. So I'm going to fold down my middle finger, flip over the back of my hand, my tan side of my hand as the video recommended. This is a ratio of root 2 over 2 divided by itself. That gives me a ratio of 1. My answer is 45 degrees. Finally, the tangent inverse of root 3. So I want root 3. I need to flip over my hand. Root 3 on the top and 1 on the bottom. That would be the tangent inverse ratio. The angle is 60 degrees. 60 degree tangent, though, is positive. So I want 60 degrees to be negative. Alright, let's go through your domain and range. I got to do this in under a minute. The domain is any ratio for a sine function, any ratio, any value of a that's between negative 1 and positive 1. You plug in a ratio, it's going to give you an output, a value for an angle. That angle can only be between negative 90 and 90 degrees, including negative 90 and 90 degrees. For a cosine function, you can plug in any ratio as long as that ratio is between negative 1 and positive 1. The range of values it's going to give you is any angle of theta that's between and including 0 and 180 degrees. Finally, for your tangent domain is all real numbers. And tangent value can be defined for any ratio. The range, though, has to be an angle. It's going to only return to you an angle that's between negative 90 and 90 degrees. I want you to notice one last thing in the last 15 seconds of this video. I am not including negative 90 and 90 degrees. How come? At negative 90 degrees or 90 degrees, your tangent ratio is undefined. This concludes video 1. Please move on to video 2.